How you going, Year 7? Welcome back to another video. Today, we're going to look at adding and subtracting fractions. Okay, so this is kind of where we've been leading up to in the last few lessons, looking at converting or changing equivalent fractions, looking at simplifying fractions. Today, we're going to learn how we add fractions together. Now, to do this, we just need to imagine a real-life scenario. Okay, imagine you had a piece of paper, okay, you cut it into 5 bits, okay, so you've got 5 bits, they're going to be 1/5 each, okay. Now if you took 2 of those bits, okay, and then had 1 of those bits as well and added those together, you would end up with 3 of those bits, okay, you would have 3/5. So notice that when we add fractions, we add the top number, the numerator, but we don't add the denominator, okay? Because we're just talking about how many bits do we have, okay? If we have 2 bits plus 1 bit, okay, then we have 3 bits. In this case, those bits are fifths, okay? So just add the top numbers, don't add the bottom numbers. So 2/5 plus 1/5 equals 3/5. The 5 stays the same. Don't add those together. I don't want to see 3/10 because that's not true. Okay, we've got 2 bits plus 1 bit, which is 3 bits, or 3/5 in this example. Okay, now when we subtract, it's the same deal. That was question A. Question B, if I have 6 bits and take away 2 bits, then I'm left with 4 bits. These bits are 8s in this case. So the 8s doesn't change. We don't go 8 minus 8 is 0. We just go 6 minus 2 is 4. And then the 8 stays the same. Now, what we want to try to do is simplify our fractions so they're always in the simplest form at the end. So 4/8 is what we're left with, but we know that there is a common factor between 4 and 8. We can divide both the top and bottom by 4. And we will end up with 1/2. Okay, so we want to first subtract the top numbers, leave the bottom number if that bottom number is the same, and then simplify if we can by dividing by a common factor. Okay, so watch that again if you are not quite sure. If you haven't got it the first time, watch through the video again. We're going to move on to these second lot of examples. This time, we're adding fractions, but what do we notice? It's 2/3 plus 1/4. In this case, the bits, okay, the size of those bits are different. We've got thirds and we've got fourths or quarters. So we can't just add them together and go 3/4 or 3/3 because the size of those bits are different. So what we need to do first is change them into an equivalent fraction where the denominators are the same. So we've got to think, what is a number that both 3 and 4 can multiply into? Okay, and the answer is going to be 12. Okay, because 3 times 4 is 12. We can multiply both of these numbers to equal 12 easily. So for 2/3, if we want to equal something 12ths, we're going to times top and bottom by 4, aren't we? Okay, for a quarter, if we want it to be 12ths, okay, equals something over 12, we're going to times top and bottom by 3. So it becomes 3/12. So now we have a new question where we can just add it like we did in those first questions because the denominator is the same. So it's going to be 8/12 plus 3/12, okay, which equals 11/12. Now 11 and 12 don't have a common factor, so that is in the simplest form. We don't have to do anything else. Okay, so that is how we go about adding fractions when the denominator is different. Let's try subtracting in the same way. So looking at example B, we've got 9ths and we've got 5ths. We've got to convert it so they have the same denominator. We're going to find a number that both 9 and 5 fit into. Now, the easiest way to do this is if we multiply 9 and 5 together, we get 45. So we know that both of them are going to fit into 45. So we're going to convert them into 45ths. Okay, it's a big number, but that's the way we're going to go about it today. So 7 over 9 becomes something over 45. We're going to times top and bottom by 5, top and bottom by 5, so it equals 35 over 45. Okay, it sounds complicated, but it's fine. Okay, so then we've got 1/5, and we've got to convert it into something over 45. We're going to times top and bottom by 9 to get 9/45. Okay, and now we can do this as a simple subtraction. So it's going to be 35 over 45 minus 9 over 45. And we can just do that. 35 minus 9 is going to be 26 over 45. Now we just got to think, can we, is there a common factor between 26 and 45? So the common factor, the factors of 26 are 1, 2, okay, and 3 can't go in. So it's going to be 1, 2, 13, and 26. Unfortunately, none of those are a common factor with 45, so we can't simplify that. So that is going to be our final answer there. All right, last lot of questions. Here, we're subtracting, but we're subtracting from a whole number. So we need to work out how are we going to do this. We've got a whole number here. So what we're going to do is we're going to convert that whole number into a certain number of the bits, okay, of those fractions. So in that first example, we have thirds. We're taking away 2/3. So we're going to convert 3 into something as thirds. Now, if there are 3/3 in a whole, there's going to be 9 thirds in 3. Okay, so 3 is the same as 9 over divided by 3, or 9 over 3, 9/3. And then minus 2/3. And our answer, then now we have the same denominator, we can just subtract and we get 7/3 as our answer, or 2 1/3 if you want to convert back to a mixed numeral. Okay, so again, the same principle applies with whole numbers. Convert them so they have the same denominator as the fraction. So same for B. We want to convert 6 into ninths. So if there are 9 ninths in 1, there's going to be 6 times 9 ninths in 6. So 6 times 9 is 54. So 6 equals 54 over 9. And then we're going to subtract 5 over 9. And it just becomes a simple subtraction of the top numbers when you have the same denominator. So it becomes 49 over 9. Now, 49 and 9 don't have any common factors, okay? It's 7. 7 doesn't go into 9. So we have got our final answer there. Okay, so moral of the story is make sure they have the same denominator and then add or subtract the denominators. That is, make sure the bottom number's the same first, then subtract or add the top numbers. Okay, good luck with today. Let me know if you have any questions. I'll see you in the next video.